In this next section, we're going to look at linear and absolute value inequalities. And before we start, let's take a look at some properties of inequality, which look a whole lot like some properties of equality. So the first one, if A is greater than B, then A plus C is greater than B plus C. A numerical example, let's say that 5 is greater than 2. And what this is telling us is we can add the same number to both sides and the inequality should still hold. So 5 plus 3 should be greater than 2 plus 3, which it is. Now the next one, if A is greater than B and C is greater than 0, so that means C is a positive number, then A times C is greater than B times C. Okay, so we can multiply by the same number on each side of the inequality. Okay, so again, we'll start with 5 is greater than 2, and then we multiply by a positive number. And so I'm going to multiply by 3. So 3 times 5 is greater than 3 times 2, okay, because 15 is greater than 6. But there's this other form of that same property, and it says if A is greater than B but C is negative, C is less than 0, then A times C is less than B times C. Okay, so we'll start again with 5 is greater than 2, and let's multiply by a negative number this time. So negative 3 times 5 is something compared to negative 3 times 2. And this is negative 15, and negative 3 times 2 is negative 6, and negative 15 is less than negative 6. We see this inequality symbol flip in the middle of the problem. Okay, and that is also true if you divide by a negative number. Okay, we have some absolute value inequalities, and the first one says if the absolute value of x is less than a, then negative a is less than x is less than a. Okay, so let's see how this works. So we have the absolute value of x is less than 3. If we look for values that would satisfy this inequality, we can take a look at numbers somewhat that are less than 3. So 2, absolute value of 2 is 2. So 2 would definitely satisfy the inequality. 1 would, 0 would. Any fractions between them would also satisfy. But take a look at some negative numbers, like the absolute value of negative 2 is 2, and 2 is less than 3, so negative 2 would even work. However, a number like 4 or negative 4 would not work. Even 3 and negative 3 do not satisfy this inequality. So what we end up doing is shading this region, and this region is all real numbers between negative 3 and 3. And therefore we can rewrite it as this compound inequality. X is between negative 3 and 3. Okay, well, if the absolute value of x is greater than some number a, then we end up with this other type of compound inequality, which is called a disjunction, that x is greater than a or x is less than negative a. Okay, so this time we're going to look at when absolute value of x is greater than 3. And some values of x that would satisfy this inequality are numbers like 4, 5, 6, but even some negative numbers like negative 4, since the absolute value of negative 4 is 4, and 4 is greater than 3. Numbers that are very close to 3 will work as well, so 3.001 or negative 3.001. Those work, but 3 and negative 3 do not work, and numbers between negative 3 and 3 don't work either. So what we end up shading are numbers that are just greater than 3 or less than -3. Well, we have another way to express solutions when there's an infinite number of answers, such as one like x is greater than a. So if x is greater than 5, for instance, we know that there exists an infinite number of x values that would satisfy this inequality, because numbers that are greater than 5, they're not only integers like 6, 7, 8, but they're irrational numbers or rational numbers that are, fractions or decimals. So 5.001, 5.00001, within any two numbers on the real number line, there's another number. So it's really hard to write down that list of solutions. If I just wanted to write them out, I would be writing forever. Instead, what we're going to do is just shade on the number line. I'm going to put a 5 and then shade to the right, because that's what this inequality reads, is that any of these x values that are greater than 5, okay, and larger numbers go to the right, smaller numbers are to the left. And then we're going to write this in another notation called interval notation. And so in this case, in every case for interval notation, read the number line from left to right, and whatever the first value that you have shaded or gotten close to shading is going to come first. So 5 comma, and then we've shaded numbers all the way to millions and billions, trillions, etc. But we can't even stop because there's not an end to our number line. So we're going to just say that this is going to infinity. Every time you write infinity, put parentheses next to it. But the 5, I have two choices. I could have a bracket, and I would use a bracket if the 5 were shaded in. Otherwise, use parentheses, and that just represents this open circle that the number 5 does not satisfy this inequality. Okay, well, what if x is less than 5 instead? Okay, so I'd draw 5 on the number line. We're going to shade to the left because these numbers are smaller than 5. We're not including 5 because this does not have an equal to. The inequality symbol is just a less than. And therefore, we can write this interval as negative infinity. Okay, start with the smallest number you see shaded in, and then 5 is the last number that's almost shaded, so we're going to write it down and put parentheses next to both of those. Okay, if we're given a conjunction, which is a type of compound inequality, A is less than X, which is less than B, we could have something like 2 is less than X is less than 5, or what this could be read as X is between 2 and 5. Okay, so we're going to draw a 2 on the number line and a 5, and any numbers between them would satisfy this inequality. So I'm going to shade between. I'm not including the 2 or the 5. And then we'd write our interval starting at the first number 2 to the last number 5 with parentheses around both. And another example, if we have this disjunction, x is less than a or x is greater than or equal to b, let's take a look at a numerical example. X is less than 2 or x is greater than or equal to 5. Okay, so we're going to just take these one at a time. I put a 2 on the number line, and because x is less than 2, we're going to shade to the left. Okay, or x is greater than or equal to 5. So I'm going to draw a 5 on the number line, shade the 5, and to the right. And because this says or, that any number in either of those regions would satisfy this inequality. So we want to write both regions down. So the first region, the region on the left, would start at negative infinity and go to 2, parentheses. The second region, the region on the right, would start at 5 and then go to positive infinity. Now the 5 is shaded in, so I need a bracket next to 5. And because that the solution includes 2 regions, we need to unite them with a union symbol. And so this union symbol looks like a capital U.